So this time, if you have two, root, you have division. Two numbers divided within the square root. This is the same thing as root of a divided by root of b. Okay. So we have to go forwards and backwards, okay? Forwards and backwards. Now, I'm not going to prove this one. I really strongly recommend you try proving it yourself, just using the same technique. So, go back to the property 2 proof. Watch the video again if you have to. Okay, just try proving it. Let's continue and let's see how we can use this as an example. For example, if you have a root of 4 over 9. Okay, root of 4 over 9. Okay, if you don't have this property, this is what you have to do. You have to somehow know magically that this is 2 over 3 squared, so the answer is 2 over 3. You can do that. I mean, it's not extremely hard, but it's kind of hard. The easier thing to do is this. You use this property and go, this is root of 4, and this is root of 9. Therefore, it's 2 over 3. Okay, so this is the more intuitive method. Does that make sense? Right, this is some, you have to do more calculation in your head, right? I guess you could do it like this. It's like square root of, this is 2 squared over 3 squared, so you get, that's 2 over 3 squared using the exponent property. That's why it's 2 over 3. But I think it's easier just to do this, right? Because we're doing square root, so let's keep up with the square root properties. Okay, here's another neat property. Okay, let's say you have 1 divided by root 2. Okay, 1 divided by root 2. So roots, right? Every root actually has 2 equivalent expressions. 1 divided by root 2. Clearly, we can't simplify anything here, right? In terms of reducing. But here's what we can do. We can multiply the top and bottom by root 2. Let's see what happens. If you do that, the bottom becomes root 2 times root 2. The top becomes root 2. What is the bottom equal to then? Okay, we can't simplify anything here either. But by doing this, which is just multiplying by 1, I converted 1 over root 2 into root 2 over 2. Okay, so let me tell you, it's a little bit long story why this is better. But generally, okay, we consider this to be the simpler form. Even though this looks simpler. It's simpler form because when we actually talk about dividing a square root number by 2, so we don't want to divide by square roots. So think about it, like root 2. Do you guys know if you punch that in the calculator, right? You get like 1.414. It goes forever, right? Imagine doing long division on 1 divided by root 2. It doesn't even end. Imagine doing long division on this. This is ridiculous. But on the reverse, 1.414, you divide that by 2. Isn't that like not bad? We can quickly get up to certain decimal points. So this is actually a more scientific, correct way to do the calculation. Of course, they have 2 algebraic expressions, 2 expressions that are equal. But most of the time, we consider this to be a simpler form. So state your answer so that there's no root at the bottom. Okay? So let's apply the same technique. You're actually multiplying by 1, but you don't. Instead of writing 1, you just write root 2 over root 2. When you do that, at the bottom you get 2, at the top you get 2 root 2. But what about this 2 and 2? We can reduce. So we get root 2. Simpler, right? Clearly here, this is simpler. Okay, let me show you an alternate method. Okay, isn't 2 the same thing as root 2 times by root 2? You can also do it like that too. But here we got lucky though. Here we got lucky because 2 happen to have a factor of root 2. Okay, we can't always do this. So for example, here the only way to simplify is to multiply top and bottom by root 5. Because, like, imagine I change this 3 into root 3 and root 3. Does that help at all? Does it reduce? It doesn't, right? So it doesn't actually help to do it that way. The other method that I showed you in the previous question, it was just sometimes if you have like a 5 and the same 5, you can use that technique. But if it's different, you got to stick with this technique. So the bottom becomes 5 and top becomes 3 root 5. Still no root at the bottom. This is considered simpler form.